Hey you guys, this is Unit 3 Notes number 1. Go ahead and write down the FLT here. Um, Welcome back. Hope everyone's doing well. Okay. Press play whenever you're ready. So here, given a right triangle with two known side lengths, you're going to be able to find the exact and the approximate length of the third side using this concept that we call the Pythagorean Theorem. So you should have seen the Pythagorean Theorem at least once in the last few years. But nevertheless, even if you haven't seen it or if you might not remember, this will serve as a good refresher for you, okay? Now, something to keep in mind, you want to make sure that you know what the difference is between exact and approximate. So I'll go over those in every problem there, but just to show you kind of the concept of it. So this mathematician, Pythagoras, he noticed that there was a trend with the three sides of a triangle, specifically with a right triangle, okay? So he basically said that given a right triangle, so you have to know that you're given a right triangle. This doesn't work for all triangles, okay? But for specifically right triangles, he labeled it A, B, and C. Now C serves as what he named it as the hypotenuse. Okay. Remember that the hypotenuse is always opposite of that little right angle right here, okay? Notice how it's always the opposite. It's the longest side of a triangle. Now, sometimes the longest side is kind of tough to see. So just remember that the hypotenuse, no matter how they draw the triangle, the hypotenuse is always opposite of this right angle right there, okay? But he basically noticed that if you take the sum of the squares of the legs, so these two are the legs. If you take the sum, which means the plus, of the squares of the two legs, that's equivalent to the square of the hypotenuse. You guys know it as a squared plus b squared equals c squared, right? And this works for all right triangles. Okay? Quick story here. Back then, way back then, female mathematicians weren't acknowledged. They thought that math was really only for the dominant male culture. But Pythagoras actually, what he did was he worked with another mathematician, and she wasn't getting a lot of credit for her work. So at that time, he figured if he couldn't really represent her work, what he could do is kind of honor and acknowledge her. So her name was actually Hypatia. And he actually named the hypotenuse over her, kind of dedicating her work. Okay, so a little history fact about that. Okay, so that's where hypotenuse comes from. It comes from the mathematician Hypatia. Okay, some say there was a love story, but I'm not too sure about that. Okay, all right, so here we go. So what I want you guys to understand is if I were to draw right triangles in many different rotations, okay, you should be able to figure out the hypotenuse every single time. Now, the legs, they don't matter because you're just adding up the two legs, the squares of the legs, I should say. And adding, the order doesn't matter, so it doesn't matter if you flip the legs around, right? But hypotenuse, you should know. So what you do is you take a look at the right angle, all of the right angles, and the side opposite to it is always going to be the hypotenuse. That's something that I want you guys to pick up right away. Okay? Notice how opposite of that right angle that's always going to be your hypotenuse. Okay? So no matter how they rotate this triangle to confuse you, just understand that the hypotenuse is always opposite of that right angle. Okay? All right, so here's example 1. Okay? I'm going to go ahead and write down find the third side length. And then I'll put exact and approximate. Okay? Now on Delta Math, every problem is slightly different, so you want to make sure that you read the question carefully, okay? So I'll show you what you would do if you were asked to find the exact answer or to approximate it, okay? Okay, so here we go. So let's say I had a triangle like this, okay? And you guys should know right triangles should always have that perfect L shape. So make sure that when you guys are drawing it, it's that perfect L. You don't want to, draw something like this and call it a right angle. Okay? It's not a perfect L shape. So anything that's a perfect L, and you might have to kind of turn your paper around to draw that perfect L shape, right? That'll give you that right angle. Okay, so let me get rid of this highlight here, not to confuse you. Okay, so we'll start off with something basic here. Let's do 2 and 3. Okay, so first thing you want to do is you want to make sure that all sides are labeled here, okay? We have 2 given sides. They happen to be the legs, okay? And it's not the hypotenuse because I know that the hypotenuse is opposite of the right angle. So right here, what we're missing is our C, okay? And since this is a right triangle, we could set up the Pythagorean Theorem, which is a squared plus b squared equals c squared. So you guys could write 2 squared plus 3 squared equals c squared. You could even do 3 squared plus 2 squared equals c squared. Okay, the legs, you could switch the values around and still get the same answer, okay? But what you don't want to mix up is your hypotenuse, all right? So I'll just stick with this first one here. Now what you have to do is to solve for the unknown. So in this case, our unknown variable is that c right there, okay? C happens to be conveniently isolated, sort of, so we don't have to move a lot around. So here we go. 2 squared is 4. 3 squared, remember 3 squared is 3 times 3, which is 9. Okay. Now here, 4 plus 9 will just give us that 13. Okay. And at any point, you guys, feel free to pause and replay. Don't just move on if you don't get it, okay? Now that C is almost by itself, okay, notice how there's a little square right there. So to get rid of that square, the opposite of squaring something is to square root. And what I do to one side, I do to the other, okay? What happens here is that square root and that square will cancel out because they're opposites, or in this case, inverses. So now C will equal, now usually it's a plus or minus, but since we're dealing with side length, it's always going to be positive, okay? Now, we have the square root of 13, okay? Now, is there a number, a whole number times itself that'll give you 13? Right? So, just to sidebar this, the square root of 25 is 5, because 5 times 5 will give you 25. But with 13, it's not a perfect square, so here's what you do. If they asked for the exact answer, okay, you would write the square root of 13. If they asked you to approximate or to round, you would have to punch this into your calculator, okay? And if you have a calculator, that's great. If not, you can use the calculator provided on Delta Math. But what you would be doing is you would be typing out the square root of 13. Let me go ahead and do that with you guys. Okay, so the square root of 13 okay, so if you type this into your calculator, you should get like 3.605555127 yada yada yada. Okay, I actually use my iPhone. I went to the calculator app and then I turned my phone sideways for the landscape view. You should be able to see the square root button. Okay. Now, if they ask you to round to the nearest tenth, the 10th place is this right here. So you look at the digit after. Since the digit after is not 5 or larger, we keep it at 3.6. Okay, so if they ask you for exact, you would write the square root of 13. If they ask you for approximate or to round to the nearest 10th in this case, you would write 3.6. Okay, so pay attention to that. Let me know how that is, okay? Let's try another one. Here we go. Here's part B. Let's say I were to draw it like this, okay? Okay, and sometimes it's helpful to turn your paper sideways if you don't know how to draw that perfect L shape for that right angle. So let's say we had, let's do, okay, go ahead and try this one here. And press play whenever you're ready or if you're stuck, okay? Okay, here I first noticed that what I'm missing is my hypotenuse, so I'll call it C. Okay, and I know it's my hypotenuse because it's diagonal from the right angle. So I know that 3 squared plus 5 squared will equal C squared. Okay, so now 3 squared is just 9. 3 times 3 is 9. 5 squared, 5 times 5 is just 25 equals C squared. Okay, 25 and 9 makes 34. And to isolate C, to get rid of that square, we have to do the opposite or the inverse, which is square root. So C equals the square root of 34. Is there a number times itself that'll give me 34? In this case, there isn't. So I'll write it as the square root of 34. That will be my exact answer. Now, if I ask you to round it to the nearest 10th, okay, think about what you would get there. I'm going to go ahead and type that in as well. Let's see. Square root of 34. I'm getting 5.83095 and so on. So to the nearest 10th, that'll be 5.8. Okay. So just to reiterate, on Delta Math, sometimes they'll ask you for the exact answer. Sometimes they'll ask you to round it to the nearest 10th. Okay? So there we have it. All right? Okay. Some other things that you may see. Here we go. Here's part C. Let's say we had this right triangle. Okay? And let's say I gave you side lengths okay. Now, first thing you want to do, just like all the other problems, is identify your hypotenuse. Okay? We know that our hypotenuse is always opposite of that right angle. So this right here is my C. Okay? And the other ones, I'll just label as A and B. Okay? So the missing value here is either A or B, depending on how you labeled it. But Notice how in parts A and B, we had a hypotenuse missing. In part C, we actually have a leg that's missing, okay? So we're going to set this up the same way. We can say that this is a squared plus 3 squared equals 5 squared. Okay, so notice how the setup is a little bit different depending on which side you're looking for. All right. Okay, so in this case, my variable is a, but we're going to try to solve this very similarly to the last few. 3 squared is 9. 5 squared, 5 times 5 is 25. Now, your job here is to solve for the variable. Now, is a by itself, right? Definitely not. There's a square here, and then there's this plus 9 right here. So we're going to go ahead and try to move the constant first. We don't want to go ahead and start square rooting because we have this plus 9 right here, okay? So to get rid of a plus 9, we're going to do the opposite, which is minus 9. And what we do to one side, we do to the other. Okay, to keep it balanced. So now what I have is a squared equals 25 minus 9 is just 16. All right. Now that I have the square by itself, I know how to get rid of it because the opposite of a square, the inverse of a square is just the square root. Okay. Now a here will equal the square root of 16. Now, is there a number times itself that will give me 16? Okay, there is. 4 times 4, or 4 squared, will give me 16. So my answer is 4 here. Notice how I don't put the square root, because there actually is a value that will multiply itself to give you 16. So this here is actually my exact, but also my approximate. Okay, it's really the same thing because it came out as a perfect square. Since this here was a perfect square, there was really no need to use a calculator to get an approximation, okay? So sometimes it comes out really neat, sometimes it doesn't. So just keep that in mind. So we found out that this side here is 4. In fact, 3, 4, 5, you guys, is a very, very common, what we call a Pythagorean triple. It's a very common 3 sets of numbers that we use for a right triangle, 3, 4, and 5. Okay, 5 being the hypotenuse, okay? There are other ones like multiples of 3, 4, and 5, so like 6, 8, and 10, but there's also weird ones like 5, 12, and 13. But the one that I want you to remember is 3, 4, and 5 because it's used so often there, okay? Okay, so again, notice how in part C, you have to solve for one of the legs, which is a little bit different. Okay, so I'm going to have you guys try one more, and I think we're good to go. Here's part D. Let's draw it like this. Okay, and remember, you're looking for those perfect L shapes, okay? Make sure that you're drawing it as accurately as possible, okay? So here I'll give you, let's do, let's do 10 and 4. Okay, go ahead and try this on your own. Identify what you need to identify and then go as far as you can. Okay, press play when you're ready. All right, so first thing you should have done, hopefully, is identify the hypotenuse, which is always opposite of that right angle. So right there, they actually gave us our hypotenuse. So what we're missing is one of our legs. It could be A, it could be B. It doesn't matter if you have it switched, okay? So to set up our equation, that'll be 4 squared plus B squared equals 10 squared. If you wrote a squared plus 4 squared equals 10 squared, that's still the same thing, okay? You're still solving for one of the legs. Okay, so I noticed that B is our variable here, but we solve it the same way. Okay, so I'll bring everything down. The b squared, 4 squared is just 16. 10 squared, 10 times 10 is 100. Okay, now to get b by itself, I need to make sure that I get rid of the square, but I also get rid of that 16, right? So before I can get rid of my square, I have to get it by itself first. So a good first move is to get rid of that 16. Opposite of a positive 16 is a negative 16. What I do to one side, I do to the other to keep it balanced. All right. So now I have b squared equals 100 minus 16 should give me 84. Okay. Now that I have the square by itself, I can get rid of it by square rooting the inverse operation. And is there a number times itself that'll give me 84, right? 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100. So there really is no number times itself that will give me 84. So my exact answer would be the square root of 84. Now if I ask you to round it to the nearest tenth, I would use my calculator. So go ahead and turn on your calculator there. The square root of 84. If you're using your iPhone, that'll be 84 and then you press the square root button. You should get 9.1651513 yada 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 yada. But to round it to the nearest tenth, since the digit after the 1 is larger than 5 or 5 or larger, that's going to be 9.2 you're going to round up. And that's it. Okay, so make sure you understand the difference between solving for a hypotenuse and solving for a leg, but also what's the difference between exact and approximate. So again, pay very close attention to when you're doing your Delta Math homework, because some problems will ask you for the exact, some problems will ask you to approximate, okay? Text me if you guys have any questions, all right?